Okay, we're back, and let's do a few more things about radicals and roots, because we want to be able to put these things together. Now, first of all, we want to discuss this idea of square roots. So it's probably really helpful if we just sort of focus for a moment on some definitions about roots. Right? When we talk about square roots, what is a square root? A square root is given by this definition right here. The square root of a is equal to b implies that a is equal to b squared. So when we write out our expression, we're going to write the square root, let's say, of 16 is equal to 4, because we know that this implies that 16 is 4 squared. But square roots are not the only kind of roots. We also have cube roots, right? Cube roots is where we're taking the third root of whatever number is under the radical symbol. So we can write that, for example, that the cube root of 8, we know that to be 2, right? Because that implies that 8 is the result of taking 2 times itself 3 times. Fourth roots are very similar. In a fourth root, when you see the little 4 in the hook here of this radical symbol, then that implies that the number under the radical is the result of multiplying a number by itself 4 times. If, for example, I were to take the fourth root of 16, I should get 2. And the reason for that is that, well, 16 is the result of multiplying 2 by itself 4 times. Whatever this number here is under the root, right, that we're looking for how many n times it's been multiplied. The only time we don't write a number in that hook is when it's 2. That is the lowest kind of root that we can have. And actually, we can give a little bit about that notation right here, just so you guys are aware. When you see these symbols, this symbol right here is actually called the radical. So when we say radical something, the radical implies that that is our expression that we're dealing with right there. Okay, so that is the actual symbol. It's called a radical symbol. When we have a number underneath the radical, that is called our radicand. So the proper word to remember here is radicand. That's the number we're taking the root of. And of course, n, that number, is the index. It's called an index, and the index tells us which root we're dealing with. The fourth root, we have a 4 in the little hook there. That is our index of 4. In the cube root, the index is 3. If there is no index shown, the index is assumed to be 2, right? So that's a very important little point to remember right here. If the index is 2, the index is not shown. It's only assumed that that's what it is we're talking about. Okay, so that's a very important point. So let's talk about this. Let's define the radicals and the rational exponents, because that radical notation is sort of interesting, right? By definition, if we write a radical, the nth root of some number a, we can also write it as a to the 1 over nth power, which I know seems a little weird, but in fact it actually really makes sense. So if I said express 5 raised to the 1/2 power as a radical expression, what I really mean to say is the square root of 5, right? Notice that the index right here is 2, so it's not shown in the index position. Okay. And we could work it the other way around. If I wanted to express the 5th root of t as an exponential expression, I'm going to write this as t raised to the 1/5 power in exponent notation. Again, notice that the denominator of the fraction is the index. Okay, so that's the basic thing. Now, of course, if we have a fractional exponent, we can use this rule. It says if we have a fraction in the numerator and the denominator, where we have a numerator denominator, the numerator is something other than 1, then in fact we have the nth root of the number a to the nth power. But we can also express that as the nth root of a and that quantity raised to the nth power. All right? So for example, if I wanted to express x to the negative 2/3 as a radical expression right here, I need to take 2 steps. Of course, I need to get rid of the negative in that exponent, so I could write it as 1 divided by x to the positive 2/3 to begin with. But in that fractional exponent, the index here is 3. And 2 is the power, so we could write this as 1 over the cube root of x squared, or using our second kind of notation, we could write this as 1 divided by the cube root of x quantity squared. Okay? Both would be acceptable and express exactly the same thing. All right, one more. Let's try and express this one. If we had 2x squared, the cube root of 2x squared, we wanted to put this as an exponential expression. Well, here's what we could do right off the bat. We could just rewrite this by saying this is 2x squared, and that quantity raised to the 1/3 power by our definition right here at the top. So 2x squared raised to the 1/3 power. Now, if we wanted to do more, I suppose that we could distribute that 1/3 and say, well, this is the same thing as 2 to the 1/3 power, which would be the cube root of 2, whatever that happens to be, times x to the 2/3 power, because if we multiply 2 times 1/3, we get 2/3. So this would be another way of expressing all of this. And by our definitions, this is the way this one works.